and thank you everyone for being here. Thank you to Foundry for inviting me. I'm going to try something a little different here. I'm going to live stream a slideshow. Right. So, again, thanks for having me. I'm going to talk through the process that we went through in adopting, choosing to adopt Katana, choosing to adopt USD at the same time, essentially. I'm going to cover some of the challenges that we faced adopting USD and some of the, again, the challenges that we faced with getting data through a USD pipeline, basically figuring all that stuff out from scratch, and then quickly touch on a couple of things that we have left on our end to still polish up. So how did we get here? In late 2016, we had just wrapped Doctor Strange, and that show really broke our lighting pipeline. Even with you know, the tricks, the optimization tricks like GPU proxies, we really hit the wall in terms of scalability and how far we could push things. So we had to go back and find a more scalable and flexible solution to build a new lighting pipeline on. And by that point, we had been keeping an eye on Katana for some time, and we felt that Foundry had brought it to a point where we were comfortable, like personally, building a new pipeline on top of it. Coincidentally, USD had also been recently open sourced by Pixar. We had been keeping an eye on that as well, sort of in the lead up to that. And we essentially took the view that USD was going to be the future of our pipeline specifically, and also of a lot of other pipelines more generally. Obviously, by adopting USD, you essentially are leveraging Pixar's internal development experience and their experiences using it in production. So you get a huge advantage in terms of technical acumen on your side. And by deploying it with Katana at the same time, we recognized that we could build tools and workflows. We were going to be building new tools and things in Katana regardless, but by doing USD at the same time, we wouldn't be writing tools that were sort of temporary or going to be obsolete in a short amount of time. And sort of as a testament to how solid USD was as a foundation, and also how approachable and intuitive it was to build a pipeline in Katana, we actually had shots going in Spider-Man Homecoming within 3 months of actually starting this pipeline conversion. So just quickly touch on some of the immediate benefits of Katana, especially for us. Some of this will be very familiar to you, those of you who use Katana. Katana is a recipe tool. So you are describing how to build up a 3D scene as opposed to actually describing the contents of the 3D scene. And this, because of the recipe-based approach, this really lends itself well to templating and taking pieces of setups and reusing them and sharing them between artists, sharing them sequences and shots. Another big advantage is the deferred evaluation model, which essentially boils down to you only pay for what you need. So one of the things that we struggled with a lot in our previous lighting pipeline is when you're going to render something, you have to pay the cost to load a 3D scene into the host application before it can even start sending it to the renderer typically. And so you're essentially wasting a bunch of memory, wasting a bunch of time. And that essentially goes away with Katana. And also, it has a really solid foundation. By one of the best attributes of it, in my opinion, pun sort of intended, I guess, is that all scene data is essentially democratized. So everything that flows through Katana is handled using the same set of underlying principles. And that means that you can basically access and edit anything flowing through your scene using a very well-defined set of tools, which you can obviously build on. And one of the sort of corollary advantages of this is that it allows you to actually address some fairly complex problems directly in Katana if you have to, like in a 911 situation, without the turnaround time of having to kick things back up the pipeline and wait for them to flow back down to the lighting department. So the power of USD really lies in the sort of write once, read everywhere philosophy, the universal and universal scene description. So rather than creating all different ways for applications and tools to talk to each other. If you just teach them all to speak USD, then they all are able to talk to each other just implicitly. The schemas in USD are, they can be read and written by any tool that knows how to speak USD, but the tool doesn't necessarily have to do anything special with them. So as an example, there's a particular schema type in the Animal Logic USD Maya plugin project that basically tells the plugin to load a Maya reference. And that has no meaning, obviously, outside of a Maya context. But that prim and that data that's attached to it will live in any application that hosts USD. So there were also some advantages to starting our USD pipeline build out from the end of the pipeline rather than the beginning. So it allowed us to immediately add basic, data conversion and export steps to our existing departments without having to build a whole set of USD-centric tools from the top down. And so we could be feeding data into the lighting pipeline without having to build an end-to-end USD workflow right out of the gate. And then we could gradually push USD tools and concepts upstream into those other departments. Some of the early challenges we faced as early adopters of USD and also just in general, deciding how to structure USD data is easily the most complex and daunting part of adopting it. It's setting up a shot and saying, okay, I want this asset and I want this set and I need these cameras and so on. So we had to build some tooling around that. One of the main core challenges, which I'll touch on a bit later, is getting look dev from Katana to USD. So in order to handle that, we had to add our own schemas. We use Arnold as a renderer, so we had to add some schemas to be able to attach Arnold-specific overrides to objects as part of our look dev exports, things like subdivision parameters, visibility masks, and so on. We also had to come up with a way to get shading AOVs out of Katana into USD and then back into Katana in a way that allowed them to be seamlessly handed off to Arnold. And again, I'll touch on this a bit later. The work that we did on Arnold and USD, we eventually open sourced that as the project called USD Arnold, which was then subsequently sort of used as the baseline for the Autodesk Arnold USD project. It's hard to not get confused there. But and then we also had to do some basic work on K2A, which is the Katana to Arnold translation plugin. So basically the plugin that feeds Katana scene graph data into Arnold. So we had to add support for basic things like understanding different polygon winding orders coming in from USD and adding support for the USD point instancer schema, which is essentially like a scattering prim. Before Katana had a notion of an instance array location type or anything like that. So building on top of the foundation of Katana in terms of a pipeline, generally speaking, there are a number of different ways to skin any cat, so to speak. There's many ways to solve a problem. So depending on how much you want to automate something, how much control you want to leave in the artist's hands or take away, you can kind of be operating at many different levels in terms of functionality. One of the core things for us is really about executing multiple shots in a sequence together and being able to really leverage that templating and that shared scene description functionality. So in terms of tooling, there's a lot of automation of bringing in a bunch of USD stages from different shots in a sequence, and setting up some global graph state variables to allow the artist to switch between them. And then this also includes things like having a UI tool that knows how to deal with a matrix of shots and layers in those shots, which is it's a 2D spreadsheet problem essentially. At the extreme end, we actually at one point had one show where an artist was lighting over 100 shots from a single Katana scene, which from a management standpoint, I don't think the artist would recommend, but it does speak to the power of Katana and the scalability. And then there's also just a lot of work that goes into streamlining the artist's workflows and streamlining how efficiently they can get things done. So being able to publish templates in light rigs and have those be brought in intuitively when people are setting up new scenes. AOV management is a big one, so giving artists tools to prune or isolate specific AOVs, either shader AOVs or global lighting AOVs within their scene. There's some scattering tools that we've written. Most of these are now actually handled in other applications using like in Houdini or something like that, but there's still some tools in Katana for, say, light scattering. And then, you know, we had to add in color management support, OpenColor.io integration in both in terms of integrating it with our pipeline OpenColor.io setups, and then also pushing that config through to Arnold at render time. So now I'm gonna touch on some specific case studies of data flow from USD through Katana to Arnold and how we had to address some of them. So first up, this is essentially the backbone that we're dealing with. So the idea here is that we want to be able to produce data from an application like Maya or Houdini, and we want it to write data to USD in such a way that it will flow through Katana without anybody having to manipulate anything, and have K to A, the Katana to Arnold translator, be able to understand it and produce data in Arnold that matches what is coming in from USD. So in order to do this, we had to, we decided to basically break down, like, I'm not expecting to sort of analyze this, but this is just an example where we're breaking down here the different applications and different types of objects and shapes and things like that, and then how they represent different attributes in those different applications. So by doing this, we sort of mapped out where the deficiencies were, where the missing pieces were, and that informed which part of the sort of translation process we needed to address it at. So specific example, I have a few of these. Basically, one problem is that we wanted to be able to use direct shading component connections, which is something that most renderers don't actually support without using sort of intermediate swizzle nodes where you feed in a color and then it gives you three outputs, R, G, and B, and then you can wire those into other shaders. Arnold actually lets you directly connect the components of a vector output or a color output to components of another, input. And so because this is something that's sort of, I don't actually know if it's unique to Arnold, but it's certainly among the major renderers. I believe Arnold is the only one that supports it. But USD Shade doesn't have any way of representing this stuff. So in order to address this, we added a custom shader schema in order to basically make it easier for us to identify these shaders when we're looking through a stage. And we had to invent a naming scheme for describing these component outputs, the out.g, out.b, in USD parlance. And then we added a plugin to USD Katana, which is the sort of the core USD library and plugins that originally were from Pixar, now maintained by the Foundry. And so we added a plugin that basically would find materials that had these component connections in them and then rebuild the Katana attributes in the material attribute so that those component connections came in properly. We also had to plumb some awareness of the Arnold-specific schemas into USD Katana itself, which we're hoping to basically move away from at some point. Longer term, we're planning to try moving away from the custom schema types for this. It seems like it's doable, but in terms of component connections, there's no silver bullet here. We've done some looking at Material X and things like that. We're not totally sure if that's the direction we're going to go. So for now, this sort of post-processing approach is probably going to have to stick around in some form. Another use case, shading AOVs. We want to be able to have look dev artists define asset-specific AOVs as part of their shading networks, and we want to export those with the asset, and then we want to have those AOVs come in and populate in a shot when the asset is added to a shot layout. So as part of this, we need to be able to package those AOVs with the asset look dev when it's exported. But because the assets are potentially being used in many shots, we can't push the shading AOVs into the shot itself when we export the look dev because there's out of order problems there. The asset is probably being worked on well before all of the shots have been created. So there's also a sort of a big problem, which is that USD didn't have any concept of AOVs. This has been more recently added as part of the USD render schema module, but at the time we were sort of on new ground there. In Katana, you have to define a output channel and a render specific channel information on the root location. And so we needed to basically be able to efficiently aggregate all of the AOVs from a scene because the assets could be mounted somewhere down in the hierarchy in the scene, and then be able to build those channel definitions on the root. So the way we approached this, we added a custom schema to encapsulate an AOV description. Is essentially just the name, the data type, parameters for the driver, and the filter. And these AOV prims were exported along with the look dev, and they were nested in the assets hierarchy, so kind of alongside the shader definitions. Then we added another USD Katana plugin that would traverse the incoming stage in Katana one time and locate all of these AOV prims, which is actually pretty efficient and fast operation. Excuse me. And then it would essentially aggregate all of these AOV prims and convert them into channel definitions in Katana. And because we read in our shot USD stages at the root location, we're able to populate those attributes in the right place. The longer term approach right now is basically the idea is going to be the same. We'll probably switch to the core USD schemas at some point. Okay, so a little more technical, hair. So generally, we want to avoid, in terms of moving into a USD-centric workflow, we want to avoid software-specific tools. So we want to avoid, in particular, software-specific hair procedurals. Usually, the reason you render hair using procedurals is because it lets you do things like render time upresing, interpolating your simulated curve so you get more density from the hair. The upshot of this, the advantages of this, are that you can simulate things faster because you don't necessarily have to have a full res groom, and you will use less disk space when you actually cache the hair sims out. Also, render procedurals really break the universal nature of USD. So by that I mean that they're really only meaningful to small, like essentially consumer at the very, very end of the data flow pipeline. Even if you have a procedural, even if you have software that's renderer agnostic, quote unquote, you still have to have separate procedural descriptions for each renderer that you're feeding. Also, because we groom and simulate hair in Houdini, if we wanted to attempt to render a procedural approach, we would need to essentially implement this using Houdini engine for Arnold, or we would need to write a custom curve interpolator, sort of a general purpose curve interpolator for Arnold, which is, both of those are certainly doable. But again, we're breaking from the USD-centric approach there. So the idea here is that if we can basically deliver the full res groom simulated in USD, then Katana will just be able to feed it to any renderer. And it will also, as a bonus, we'll be able to display it in any Hydra context. So the initial solution is not a solution. We currently just export full resolution curves prims out of Houdini. This has been fine for us for small numbers of characters. So it's, we're not immediately pressed by this. Longer term solution is we want to leverage what are called dynamic payloads in USD. So a payload is like a box of data, and you attach it to a prim, and then you can open a USD stage, but that box stays closed. And then only when you're actually ready to fully populate your scene, you open that box and all of the data from it is populated in the stage. The way a dynamic payload works is it essentially lets you set up parameters on a prim that has a payload on it. And then when the payload is open, when that box is opened, the plugin that's responsible for opening the box and feeding the data back to USD is able to look at those parameters, and then so you can potentially change the behavior of that plugin depending on how you parameterize that prim. So one really interesting idea from this is, what if we could take Houdini engine and use it as the box opener. So we can set up a prim that represents a Houdini engine node, and then set up metadata that actually drives the Houdini engine cook and produces data directly into USD. So the jury's still out on that one. Another use case, volumetrics. So basically, how do we handle them? Most renderers treat volumetrics a lot like procedurals, in that the input data, which is typically OpenVDB these days, is effectively a black box. It's not really meaningful to any application, and I'm obviously excluding Houdini here because Houdini is editing VDB data. But in terms of applications which are simply consuming it or passing it along, VDB doesn't really mean much. There's also a sort of an issue, which is that there's no standard convention for how to describe a volume location in Katana. So K2A and PRMan use volume location type, but they have different attributes on that location type. So that part is non-standard. And then 3D Light just uses something completely different. K2A's volume location, which is what we're concerned with, behaves essentially like a render procedural, because you can have custom volume procedurals in Arnold. So they essentially describe it the same way. So this all boils down to the fact that we're not really going to be able to get around any renderer specific behavior. So the way we approach this, again, going back to the well, we added a custom schema for volume prims, and we added a plugin that basically will act as an intermediate and take those prim attributes and convert them into arguments for K2A's volume location op. Now, what this op does is it's when you're working in Katana, there's a node called an Arnold VDB volume, I think. And what this will build, you give it a path to a VDB file, and it will build you a volume location that K2A understands. So by leveraging that same op, we're able to build a location that K2A will just be able to pick up. So we basically only have to do the translation when the USD is read into Katana, rather than post-processing it in Katana itself. Current iteration of this is essentially the same. We've switched to the official USD vol schemas that were added by side effects. And in order to support Arnold-specific data, we had to add an API schema to know how to bind and read those attributes back off the prims. So basically, volume handling is going to remain renderer dependent for the foreseeable future, it seems. All right. Last but not least, crowds. This one has been a recent effort for us internally. So basically, we want to be able to adapt a third-party crowd system to use USD, to exist in a USD ecosystem. We use Atom's crowd at Luma, and it is largely self-contained. It has its own file formats for things like meshes, skeletons, animation clips, simulation. So when you're creating a crowd system in Atoms, you convert your meshes and skeletons into Atoms' native file formats. Then you do your simulation, create your agents, all that stuff in Atoms itself. You spit out an Atoms-specific file type that describes the simulation result. And then you feed that to a renderer procedural in Arnold, which builds meshes from the crowd description. But we want to sort of flip this on its head a little bit. We want to basically be able to feed our USD assets into Atoms crowd and produce USD Skell agents directly. USD Skell is the schema module for describing skeletons and skin weight bindings and blend shapes that in USD. It's not crowd specific, but it does lend itself very well to crowd system descriptions. So essentially, we want to be able to leverage our asset pipeline so that we can do normal look dev on crowd agents. And we also want to take advantage of the fact that by using USD Skell, we get crowd systems visible in any Hydra context, like USD View or Katana. So basically, what this means is that the crowd system can't be the origin of like brand new data. We don't want the crowd system to be spitting out brand new assets. So the way we address this is by adding USD plugins for Atoms crowd. So these will translate USD meshes, USD Skell skeletons, and their skin weight bindings and such into Atoms' internal constructs. And this lets us feed our normal asset exports directly into Atoms. And then the other side of the pipeline. So once we've fed the data into Atoms, we've created agents in Atoms, and the simulation happens normally. And then at export time, we use a customized Atoms exporter that will sort of track which assets are used in the crowd system, and it will then create references to those. So you imagine a crowd system, you feed in a man, like a generic man, and then you create 50 copies of them, and they're all running away from something. Some of them get hit by a car, whatever it is. Excuse me. And then at export time, we say, oh, okay, this is the generic man asset. And so the exporter will create 50 references to that asset that came from upstream. And then the asset also includes a skeleton definition. And so we overlay the skeleton animation from Atoms that Atoms has simulated for us on top of each of those references. So each one gets a unique set of animation, but the underlying data is all shared. And then it also will build a USD variant set for an agent type that allows you to switch between all the different customizations that we've described for the different shirt color, different pants color. This one's wearing a backpack, this one has a gun, so on. So what this means is that a lighter in Katana actually will have the ability to change the configuration of any of the agents after the simulation has been done. So if they're in a review or something, and they're like, oh, there's two guys who look exactly the same right next to each other, falling into this hole or whatever, we're able to, they would be able to then change one of those to, guy with a backpack on instead. So the last piece of the puzzle was USD Katana does not have any way of actually doing anything special with the USD scale binding data. So we had to add something that would basically apply point deformations based on the scale animation after the fact. So this happens as a post-process essentially. So Pixar USDN reads in a normal mesh, and it will read in an agent essentially in bind pose. And then we come along and we calculate the point-based deformation for the mesh, and then we just kind of move the points around after the fact. So this way we don't lose any custom attribute data or anything like that that's attached to that asset. We have a few remaining pieces that we need to address. USD Lux adoption is a big one. We're currently just exporting light rigs in Katana, sort of a format that is Katana. It's not Katana specific, but it's tied fairly closely to some tooling in Katana. So we want to be able to switch to USD Lux so that we are able to get light rigs not only in and out of Katana, but also into Houdini. Part of this is we need to be able to describe and support Arnold-specific lights, shaders, and filters and other schemas, and also attribute overrides for lights. And then we also are planning to roll out a general-purpose USD preview surface workflow as part of our look dev pipeline. This is currently prototyped as part of the crowd pipeline so that we can have texture previews in Hydra contexts for review, so that people can tell what clothes different agents are wearing and that kind of thing without having to actually do a render. So this basically involves auto-generating preview textures from the look dev and authoring preview shaders at export time. And then there's always more work that can be done on the workflows for artists, Katana workflows, making things easier for them. So yeah, continuing to refine the artist experience. Again, thank you to Foundry for having me, and thank you all for coming.